So looking at, again, 4 problems. So this is the compounding interest formula that we did last year in logs and exponents, and we also did this year in logs and exponents. So this is like if you're solving for interest with rate and time involved in it. So the amount in your account would be equal to P, which is your principal, and then 1 plus, that 1 is there because you're going beyond your account, beyond the 100% that you already have invested, the rate times time. And I want you to solve for T. So there are a couple different ways you could solve for T. There isn't one correct way, but your goal is to algebraically get the T variable by itself. So don't all raise your hands at once. What do you think one thing you could do, Jake? Yeah, we could take the P to the other side, we could divide by P. Because then that gets rid of those parentheses. So now we have A over P, 1 plus R times D. So again, still trying to get the T by itself. So Jake, what else would you do? So subtract 1. These two terms on the left side, you will be asked to make sure it's condensed together as one fraction. So I would say condense the left side together first before you do anything with that R. So Jake, if you were asked to put those together as one fraction, there we go. How could you combine these together so that it's one term? Yeah, so this one we would really be P over P. So we would have A minus P over P equals R times T. So that's getting a common denominator, making the 1 have the denominator that the first term has. So that first term was A divided by P minus 1, which is really minus P over P. So then I can combine them, A minus P over P. And now the last thing, we would divide by R, but dividing by R is the same thing as multiplying by the reciprocal. Because when you have a fraction on the other side, dividing is really multiplying by the reciprocal. So T is now by itself. We've solved for time, and time would be equal to A minus P divided by R times P. So if I wanted to figure out how much time it would take for something to occur, and I knew what my initial amount was, I knew what I wanted my end amount to be, I could kind of gauge then how much time it would take to get there. Questions? So that's, using concepts we've done throughout all the year, just trying to isolate a variable using proper algebra. So looking at number 2, we have 1 over F equals 1 over G minus 1 over H. It asks you to solve for G. Again, a couple of different ways that you could approach this. So there's not necessarily one correct method, but you have to use correct algebra. Any suggestions about where to start? Mason? Yeah, let's get at least the G fraction by itself. So we would have 1 over F plus 1 over H equals 1 over G. So at least the G now is by itself on the one side. Mason, what do you think you would do with these two fractions if they have an addition sign?
Add them together.
And how would you add them together?
1 over F plus H.
What do you have to have with the denominators in order to add them?
Like?
Yeah, okay, so this one needs?
Oh yeah, you multiply F by each side and H by each side.
There you go. So we're going to multiply the left by H and then the right by F. So getting that common denominator, my common denominator will be F and H combined together so that you can add them. So on the top left we have an H, the top right is the F, and then that's equal to 1 over G. So once it's a proportion is two ratios that are equivalent to each other. So we have h plus f over fh, one ratio, one fraction, one term, equal to 1 over g. How could you get g to be on the top? Elena?
You just flip both sides.
Yeah, you just flip both sides. So you can't do it initially because there are three individual terms. But once you get one ratio equal to another ratio, literally you're just flipping them. So g is equal to, maybe, flipping that fraction, f times h over h plus f. But you can only do that when you have a ratio or a proportion, one term equal to the other term. So flipping, now we have a g, and then f times h over h plus f, or f plus h. You want to write them alphabetically. Any questions on the second one? So as long as you're using proper algebraic techniques, you didn't necessarily have to solve it that way, but that was one way you could solve. So question 3, another formula here, solving for the uppercase I equals n uppercase E divided by R plus NR. And I want you to solve for n. This one is a little more involved because there's two n's, one in the numerator, one in the denominator. Somehow we got to get those n's together because our goal is to have n by itself. So see what would you do first? Try and think of it like something algebraically that you could do. Morgan, what do you think?
Multiply by r plus n.
Yeah, let's get this piece out of the denominator. So she said multiply. So if we multiply that, what would that become then, Morgan?
Well, do you factor it?
Sure, let's factor it. Yeah, let's see what happens there.
I r plus I n.
So she's just multiplying to get this to the other side. R, N, R. So R, N, R. And then taking that I, distributing it through. So IR plus INR. Okay, the goal is to solve for N. What else would you do? Morgan, what do you think?
Divide by e.
Before that, how many n's do we have in the equation right now? 2. So what do you think you would want to do with those n's? We're trying to solve for n. We need to get them together on the same side because our goal is to get the n by itself. So we need to get those, pair them together on the same side. So keeping the IR, subtracting the INR. Because now we have an N and an N, and both of them are on the same side of the equation. Remember, the goal is to get the N by itself, so we need them to be on the same side so that at least they are together on one side of the equation. So what would you do to get N by itself? Elena, do you know?
Just pull it out.
Yeah, just pull it out. So because they're on the same side, both terms have an n in common. So factoring that n out, that's what we're trying to solve for. So now if I pull it out, we would have the e and the IR left over. Did I lose my little r somewhere? I think this up here. This is my fault. This is a little r. A little r. There we go. And then Elena, to get n by itself, the last thing would be,
Divide by the parentheses.
yeah, divide by this entire term. So we're dividing by the e minus I r. So now n is by itself, it's equal to I r, and then e minus I r. I knew both you physics. A couple of you have physics. Do you do a lot of rearranging variables in physics? Yes. Questions? So factoring was like the key method to use there. Get the equation, the term on the same side that you're trying to solve for, factor out that n. I think there's one last problem. Oh, this one's a good one. Trying to get p by itself. So again, a couple of different things that you could try and do. We're just rearranging the equation, solving for a variable. If we use the method that Morgan used in the previous one, you can take this whole denominator and multiply it with the m. That would be one way to start the problem. At some point, you're going to have to get common denominator. So I think, Alyssa, were you getting a common denominator first? Yeah, so you could get a common denominator first, or you could multiply to the other side and then get a common denominator. You would end up at the same location. So if we took the m and multiplied, I would have m times 1, m p n over q squared, and then n plus p. So that would be like one option. Alyssa, like this, you getting a common denominator first is not wrong by any means. Kind of just depends on what you see first. But I kind of went off of what Morgan did for the last problem, taking that whole fraction, getting it out of the denominator, taking it to the other side, and then just distributing the m through. So m times 1, and then the m p n over q squared. So then the goal is to get p by itself. So kind of switching things, getting the p's together on one side, we would have an m, I'm going to subtract n, and then we have a p, and subtracting m, p, n over q squared. Again, you don't have to do it this way. It kind of just depends on what you see. This is just one way to solve the problem. So this is where I would get a common denominator, but depending on where you are at in the problem. So my common denominator would be q squared, so I need a q squared. Our goal is to get the p by itself. So this dividing by q squared, I could take to the other side by multiplying with q squared. So that the denominator is canceling. And I finally have pq squared minus mpn. And on the other side, you could pull the q squared through, you could keep it separate. And then the last thing, we have that p in common. So q squared minus mn. And then finally we can divide just to get p by itself. So again, you could take the q squared out and leave it as m minus n on the top, divided by q squared minus m times n, or you could have the q squared distributed through. Questions? You could have gotten there in multiple ways, so that's just one way. So we could start solving it a different way by getting a common denominator initially. So it's just one way to solve the problem. Those are the only 4 examples I have. That's it. So pretty much every day this week we will go through like 4 examples. Even with the other 16 kids here, it will be the same way. We'll go through a handful of examples. The rest of the class will be then just kind of working on the homework, starting the homework. So today I have a worksheet that is on literal equations. I ask that you rewrite the problem and work through it. I mean, these problems are like essentially this is like a book problems, so there's really no room for you to kind of squeeze in. So you've got the bottom of the page that you can start your homework at, or you can just use a total separate piece of paper. So please rewrite it and solve as if this were a book. So rewrite it down below and then work through solving the problems. When you flip it on the back, there are all the answers. So they're all in there. I don't have any more lined paper because we're out of lined paper, but I do still have paper over there. It's just blank white paper. Feel free to use the blank white paper, or if you have your own lined paper,